Today we're going to take a look at the left rotation problem of Hackerrank. So I'll try to explain as neat and as short as possible, so please be with me today. A left rotation operation array shifts each of the array's element 1 unit to the left. For example, if 2 rotations are performed on an array, then the array would become 3, 4, 5, 1, 2. Because as you see here, 2 is it's gonna be like 1 and 2 is gonna go back, and it's 1's gonna go to 4, 2 is gonna go to 5 positions, and so on. So if this is the input, there are 5 elements of an array. If we want to move 4 steps, then we're gonna return 5, 1, 2, 3, 4. How are we gonna do it in Java? And today I'm gonna give you some different approach. Boom! Actually, I solved it for you. So, but I'll explain very discreetly, one sentence by one sentence. As you see here, first these two lines are importing java.util to to use the array list or some data structures like a hash map or you name it. Java.io is you need it to print out input and output. Now I have to define a solution. And the first thing I did after I figured out this problem was I try to write this example problems and try to think through what that I can do. And later on I just still after a few minutes couldn't kind of didn't have much of a clear idea how to approach and solve this problem. So what I did was I individually write i's position, index I, and then I subtracted d because that's how you move the array, right? And the moved elements of array. So if I minus equals to -4 in this case, for example, the 1 is going to be located at actually in this position 1, that's a 2. So and 3 and 2, 2 and 3 and so on. So what I figured out was, hey, look at this. After we sort of keep moving the array by d steps, right? Our new index is going to be defined as the mod, which is the remainder operator of whatever d's mod the length of an array. The reason is this d can go 100 steps, d can go 1,000 steps. We don't know how many steps that it's gonna go into, but what we want to do eventually is that's the magic of the mod operator. Mod operator, it only returns the remainder when in terms of the integer division. What that means is, yeah, of course. When you do the integer division, it's going to return how many the groups of items that you're going to get, but a remainder is sort of the thing that we want to look at it at the last minute, in the last minute. And I minus d is basically sort of the eventual position if there is no array. If we keep moving to the left side, this is sort of the final positions that the original element's going to be located. But because this problem, we need to figure out the rotation, right? We're not going to talk about the linear positioning, so we want to take the mod operator of this much of the absolute positioning, and then we just have them back into the regular array positions. So this is how I approach the problem. It can be very straightforward, but this is sort of how I think about it, and this I thought was, wow, this is really cool, because after you figure out it was very kind of quick. So this static int left basically takes the integer list and then basically the number of steps, I'm sorry. And what I did was I kind of had the trade-off of time and space, which is very common in programming. When you need to gain the time benefit, you can just compensate that for giving up little space. So what I mean by that is I instantiate a new result. In Java, when you do this, when you instantiate a new integer list, it's going to be filled up with all zeros. And after that, I loop through each element in the original list, and I check it. I check whether the final position that I have to that I move after, move these steps after that, is it going to be still 0, which means is it still not going to rotate? Is it still going to be it? Then I'm just want to locate the original position into the that much of a difference. Otherwise, I want to calculate the new index, which can be calculated by the absolute difference between these ones, right? And you see these second columns, mod operator by the length, because that's again I told you the absolute differences of how much are going to go forward, and that much of a thing, it's just gonna be located at whatever it is, So that's how you think about this issue, and later on you just populate it and you return the result array, And be careful when you fed it here. You need to be careful because when you cannot just like print the result. You need to loop through each array list, because this, when you just say, okay, I want the system data print result, then the Java is going to recognize it as two array implementation by default, which you don't want to do. And again, you can take a look at, I didn't instantiate any of the class because I'm using the static keyword here. In Java, the static belongs to the class, meaning that I don't need to instantiate each instance to get access to static. Um, in other way, I mean, on the other hand, or in other words, I mean, you can just directly get access to this static method from this class purely. So after I press this, this is 4, 5, 3, 2, 1 is exactly the input that we're thinking of, right? So I hope you enjoy my video, and I hope you subscribe to my channel, and you have a good one.